Yes, success. Let's do it. Kind of works. Okay, ignore this thing on the side. Okay, so I'm Itay Neeman. I work at Splunk. Just a quick question. How many people know what Splunk is? Show of hands. That's not too bad. Okay, so I'm going to explain what it is in one slide, and that's pretty much, I'll stop talking about it then. So it's a data engine for evented data. What evented means is any type of data that you can split into discrete events. So the canonical example that people use Splunk for is logs. So each log line or each bunch of log lines is one event. But you could also think of Twitter as an evented stream, or your purchases, or a click stream on a page, or errors that come from JavaScript, or anything like that. And then we scale Splunk anywhere from 500 megabytes a day to more than 50 terabytes a day of new data. So that's Splunk in one slide. It goes deep. The salespeople get upset when I only explain it in one slide. So in terms of buzzwords, I'll talk about big data, but really you can just take off the big. Everybody has data and they want to analyze it, whether it's just one log file a day or anything like that, or just your own Twitter stream. So it doesn't need to be at big data scale for it to be interesting. So what makes up big data, or big data? So really we divide it into three separate processes. The first process is you need to get that data into your into whatever data source or data stream that you're using. So one example is you might curl the Twitter streaming API and then send it to Hadoop or Splunk or Twitter Storm or your MongoDB instance. That's what we call ingestion. The second part is asking a question. So you have your data and you can now ask it a question. So in Hadoop, the canonical example is how many words in the total works of Shakespeare? Like what are the top words? With Splunk, you might ask, the canonical example, show me the number of times the word error has shown up in the past 24 hours. Or with Mongo, you might give it a query like show me the geospatial information using a geospatial index. But once you ask a question, you're going to get back some transformed data that you need to actually understand in order to be able to get the answer. And so the last stage that we talk about is sort of answering the data, answering your question. So you have data and you need to visualize it or understand it in some way. And so that's the last part of the process. And when I talk about real time, what does that mean? Last couple of weeks ago was a real-time conf, and there real time really means kind of two-way communication, server pushing data to the browser, sort of data being available as soon as possible. And we use a similar idea. And so we mean real time is in the data is available with as minimal latency as possible, usually within a couple of milliseconds or definitely less than a second of data. And so another way to think of it is what Splunk does. So you have historical searches, which are searches where the time cursor is moving backwards. So if I go now, I'm looking at 10 seconds ago, a minute ago, 5 hours ago. With real-time searches, what we mean is the time cursor goes forward. So you have now, and then you're looking at data a minute later, and 2 minutes later, and 3 minutes later. And so you're moving that window as time goes forward, and you can have a window that spans all of time from now until forever. So that's what we call all-time real-time. And so you can start asking questions like, what are the terms most associated with election on Twitter in a 10-minute sliding window? So that window keeps moving as time progresses. And so an example would be, send me an alert when within a 10-minute window I see the word error more than 5 times. So that's an example of sort of a real-world, real-time query that might be useful for you. And so what tools are available for sort of data analysis? So the super high in the scale, you have things like Hadoop, and Hadoop is now worthwhile if you have one log file. It's just the overhead is too big. And then there's a question of whether Hadoop is really useful for real-time data, just because of the batch notions that it has. That things like Impala make that a bit easier, but it's still not real-time in the sense that we're using here. You have things like Splunk, which we talked about. You have Twitter Storm, which is really a stream processing pipeline that you can use. You can use your NoSQL databases like Cassandra or Mongo. You can even use SQL databases like SQL Server and Oracle and Postgres have great utilities to query data as fast as possible when it's coming in. Or you can just use raw code. So you can just look at the data in Node, for example, coming in from the Twitter stream, and then just analyze it right there. But then if you want to store it, it's also available for historical analysis. That can become more complicated. If you're curious what JS for the win means, it means JavaScript for the win. If it wasn't clear to anybody involved. And so a lot of people ask, like, why are you using JavaScript for big data? Why aren't you using C or C++ or Java or something that real people use? Well, screw them. So you know how, or if anybody's been into sort of a big data talk, the big change that Google did with MapReduce with the idea that the volume of data keeps growing over time. We keep generating more and more data, and so like the saying is, something like 90% of the data that the world has ever generated has been generated in the past 3 years. So what we do then is say, okay, we can't keep bringing the data to the computation. What we have to do is start bringing the computation to the data. That's really the basic idea behind MapReduce, is saying, I'm going to send the computation to the nodes where the data lives, and it's going to compute locally and then send me a much smaller data set back, because we can't handle the large data set. But as you can imagine, that involves I/O, and so there's tons of I/O here. There's the I/O of just sort of distributing the computation. That's a lot of network traffic, and then reading the data from disk and sending the data back. And sometimes you want to sort of query secondary data stores off the database or a REST API or something like that. That's more I/O, and so this is very I/O heavy. And so why JavaScript? Well, JavaScript was baked in with the idea that I/O is evented. So when you make a REST call, you make it and you'll get a response eventually. And when you read stuff off disk in Node, you ask to read it off disk and you'll get stuff eventually. And so it's not the idea that you make a request and now you're stuck. You're waiting until a response comes in. And so really, we're going to use evented I/O. It just is such a great fit for the latencies involved in big data analysis, that you can actually use it to structure your code in a much more natural way. And the fact that all the libraries in Node and JavaScript assume that I/O happens asynchronously means that it's much easier for you to find libraries to be able to use. And then a lot of people miss this, but if you've ever tried using Python with say Gevent or Eventlet or really any of the coroutine solutions, I mean, they're great and Python is awesome, but the problem is it's not actually cross-platform. Those things will only run on Unixy things, which might be great for some of you, but if you actually have a platform that you're trying to ship for people working on Windows or Solaris or things like that, then you might have a problem where Gevent, etc., don't work on those platforms. But Node does, and JavaScript obviously does through the browsers in general. So the first step that we talked about was ingestion. So we want to somehow send the data that we have, that we're generating, to the data store. So you can do it all kinds of ways. So you can send it over TCP if you care about reliability, or UDP or HTTP if you want really structured sort of messages. Or you can just log out to a file or to syslog and tell that your data store to sort of keep reading that log file and get new data in. And that's what we do at Splunk, but you can send data over TCP as well. And the reason that sort of thinking of logging data as just logging to a file, even if it goes over TCP, is you can actually leverage a lot of great libraries that already exist in Node and in JavaScript. So all the libraries in the browser that allow you to catch the on-caught exception and log it somewhere. And in essence, that's generating a kind of log and a kind of event. Or you can use things like Bunyan or Winston to write out to a log, but that log can either be a file on disk, or it can be sending it over UDP or TCP directly to Splunk or Hadoop or your NoSQL database, etc. But one important thing in ingestion is to think, how am I going to break up my data into logical events? And it's really important to think of this ahead of time. You don't need to define a schema or anything. That's really one important thing that you can leverage from the NoSQL stores or Splunk or Hadoop, is don't define a schema, but just think, what does an event mean? So one event might be every time somebody clicks on anywhere on the site, I want to log that because I want to do clickstream analysis. Or anytime an error happens, I want to log something. Or anytime somebody makes a purchase, I want to log something. Or a check-in on Foursquare, that's an event. So think, what is an event for you? And you can have multiple event streams at once. And this doesn't need to be complicated, so this is an example with the Splunk SDK. So you can just call splunk.log, you give it a JSON object, it will serialize that JSON and log that, and then Splunk can read that JSON and do the query from there. So the second part that we talked about is asking questions. What does it mean? I have data, and it might be a lot. I might be sending. So just for scale, do people know how many tweets Twitter generates a day? Does anybody have any guesses? Yeah. So it's about 400 million today. So in each tweet, if you include all the metadata in it, is probably about a K and a half of data. It's a lot of data. So you're generating somewhere between 400 gigabytes to 600 gigabytes a day of data just for Twitter. So that's a lot of data. And if you don't do anything with it, it's not really useful. You need to start deciding what questions you want to answer from it. And so we see this pattern here that you send a query and eventually you get the data back. But we have this problem that we talked about, which is it might take a while. And the solution, like we said, is asynchronous I/O. So you ask and you will receive, but you're going to be waiting for a while. You're just going to be sitting there sort of twiddling your thumbs like, what's happening? Nothing's happening. And you'll get the answer eventually. So in this case, and it's going to be hard to see, and you can look online later. One thing that we did, a project that we did at the Splunk Dev Platform office in Seattle, is we partnered with Foursquare, and we got the Foursquare fire hose. So Foursquare has about 6 million check-ins a day now. That's about 6 to 8 gigs of data a day. And this is what a check-in looks like. So it's totally anonymized. We don't even have user IDs. We can't even group by user. So we know which venue people checked into, what the gender of the person is, what land long is, when it was created, and like the category and the time zone and things like that. But now we can actually ask a question. Oh, sorry. We can actually ask this question. What are the top categories that men and women check into on Foursquare in the past 15 minutes? So, and I'm actually indexing Foursquare on my laptop right now. And so it's all Foursquare. So does anybody have any guess what the top category for men and women are on Foursquare? Bathroom. Okay. Anything else? Gym. Okay. So let's see. I have no idea. Let's click the ask button. Look at the ask button. It's searching. It's asking Splunk the question because that's what. And hopefully it won't die. And you see, we have to wait. And there we go. So the top category is actually home. People checking at home. I have no idea why. Our theory is that you have to be the mayor of something. And your house is, you're going to be the mayor of your house unless you live with roommates or a partner that is really competitive. But if you actually did this on Tuesday when I was writing the slides, you would, the second highest was voting boost. So you can actually see sort of in real time what it is. And if you do it on Sundays during football season, you'll see that people do actually check into stadiums. So if you group by state and you ask for the top venue in each state, you'll see it's usually a football stadium on Sundays. So you get the idea that we asked a question and you saw the spinning thing was happening for a couple of seconds, and it takes a while to answer. And so 15 minutes, so if we have 6 million check-ins a day, that's about, there are about 80,000 seconds in a minute, or something like that. Sorry, 80,000 seconds in an hour, in a day. See, I can't even think. 80,000 seconds in a day, so you're talking something like 100 check-ins. Sorry. Wow, I'm not doing math anymore. Sorry, I can't do math.
A lot of check-ins per second.
A lot of check-ins. It's not that much. I think it's about 300 check-ins a second, maybe a bit less. And so you're talking a couple tens of thousands a minute, so it takes a little while to crunch those numbers. Because remember, because we're not building any indices up front because we don't know the schema for these things. So that's really the power of the NoSQL data stores and Hadoop and Splunk is sort of a late binding schema, which means that a lot of knowledge extraction happens at search time. Okay, so we asked a question and we got some data. And in the previous case, we visualized it in a table, which is awesome. Tables are great. People forget that tables are useful. So you asked a question and you even got some data back. Now what? What do we do? And real-time actually makes this harder. We said that the talk is real-time big data. But why does it make it harder? And it makes it harder because the answers keep on coming. And the reason is that real-time data never stops. You're not asking questions about things that already happened. You're asking questions about things that are happening. And let me tell you, things keep happening. And so you can think of, if you think of the sliding window concept that we talked about before, you have this case where the sliding window keeps moving, and so you keep getting new answers for each new sliding window. And if your sliding window is, say, over 1 minute and you're bucketing by second, then every second there's new data coming in. And so you need to deal with that in some useful way. And it can actually be quite hard to understand what to do. And so really the question is does visualization help us solve that? And I use visualization in a really broad sense, which is you're going to need to display your data somehow. So it can be useful, but and it doesn't have to be complicated, which is a lot of people forget. And a table, like we saw before, is a type of visualization, and a really powerful and simple one that people sort of grasp immediately. And a bar chart is just another type of visualization. But crazy flying circles where things are just moving on the screen with like some letters in them, it's not so useful. And so if you do that, then Mr. T comes online and tells you, don't make me go crazy, fool. And you see his eyes are actually moving because circles are moving around. He's going crazy. How many people here know who Mr. T is? I'm just pulling. Okay, good. I'm just making sure. So I'm from Israel, and we get shows like 10 years later, and so. I mean, I'm in my mid-20s or late 20s, and so I still watch it. It was like prime time for me, but for here, like none of my friends actually ever watched the A-Team until the new movie came on. Okay, so really something useful for real-time data is using sort of a combination of the browser and Node. And so you use Node to query the data, and part of the reason is that for high latencies and you might have many connections coming in, you can use the browser to query directly as well. And then use the browser to display that answer. And they need to communicate somehow. And two benefits of using Node and the browser as opposed to saying browser and Python, two things. One is there's a low impedance mismatch between the two because you're using JavaScript, so you can actually reuse things between. And the other reason is there are many options to enable this communication, things like dnode and socket.io. Node is just, relative to Python and Ruby and other libraries, it's very mature for sort of the real-time communication that you need. Because data keeps coming in, you really need the server to be able to push data to the client as much as possible. So why Node? We talked about some reasons, but another reason is that networking is really first class in Node. And the Node authors and the maintainers, sort of the core team, is important to say Node is going to be the platform for I/O, for evented I/O. And sort of the most common I/O these days, instead of disk, is actually networking. And also has great library support for logging to various places and getting stuff from disk and from the network. It's just a very vibrant library ecosystem. And also in Node 0.8, when they introduced streams, or I guess they did in 0.6, it's actually a great fit for what we're doing, and we'll see an example of that later. And why the browser? Well, it's really obvious. It's just a uniform visualization tool. People don't need to install Flash or Silverlight or download some client onto their machines. And so probably the most popular library right now is D3, which is great. You see the stuff they did for the election, and it's awesome. Mike Bostock is the man. But you can use raw canvas as well. SVG is not the answer for everything. And so you can actually build a really cool sort of real-time heat map visualization of latencies using Canvas, and you wouldn't build it using SVG just for performance reasons. HighChart is also a very popular library. It's unfortunately commercial, so it's paid for very rich charts. Or you can just use a table or a list, and these are also options that are available to you. And then streams. We talked about streams. So the idea is that you make a request to the data store and it's going to start streaming data to you. Well, streaming data in streams sounds like a good fit. And so, like the data is evented, the responses are also evented. You get a response for every window. And so you can imagine this as a stream that just gives you a window every single time. And so representing that as a pipeline, which is what streams are, is a natural fit. And so the response comes in from the data store, you transform it in another stream, and then you stream it out over socket.io, say, to the browser. So now we're going to put this all together. So we're going to ask a question, we're going to use Node to do it. We're going to transform that response into a stream. Then we're going to transform that stream, too many transforms. We're going to send it to the browser using socket.io, and then we're going to try and display it in a human understandable fashion. So I'll explain a bit of context about this demo, and it's a very quick demo. We partnered with Rock the Vote. They wanted to sort of bring in social media into their website. And so what we did is they gave us a list of about 60 terms that they wanted to track on Twitter. And then we indexed those terms from Twitter, and we asked a question like, what are the terms most correlated with Obama and Romney in a real-time 5-minute window? So that keeps updating. And I'll be honest, we filter out the term Obama and Romney because it's so frequent that they show up that it clouds everything else. So if you look at sizes, it will just make it not interesting. And you can actually see, like, things happen in real time. You can't see it now because the election's over. But if you did it during the debates, for example, you suddenly see Big Bird coming up, and second debate is like Romnesia, or all kinds of things, or it's like Libya, all kinds of binders full of women, all kinds of stuff comes up. It really binders because it's one term. Okay, so we're going to click the big ask button. And so it's going to go. And so I'm indexing this on my laptop right now. And it'll take a second to skip those. Okay, and then we go. And so every 5 seconds, we'll get new data from the data store, and it will update, and it'll go like that. And so actually, this is not a terribly useful visualization. It's useful when this is static, but when this keeps flying around, it makes it kind of hard to look. But we had a version of this that sort of worked in conjunction with a state map, and so you can actually hover over each term and then see which states are talking about those terms. And so my favorite one was when we did that around March for South by Southwest. It was during the Final Four of the March Madness. And like the top state in the country in terms of tweets was Ohio. And the top 3 tags were Go Buckeyes, Buckeye Nation, and Buckeyes. And then they lost. And then the top, like Ohio went down by 50% in terms of tweet volume. And the top tag was Choke Eyes. So this is going to keep going in the background, but we're done with that demo. But this is the code. And really the important parts, and I'll highlight 2 things here, is the first part, we're sort of declaring that we have a real-time stream. And this is specific to Splunk, but you can imagine it for Hadoop or Mongo or anything else, really. And the search query that we're doing is hidden. And all this is available on a GitHub repository, which I'll tweet later. So you can actually look at all the code that we use to do this. And it's not that much. And then we have this transform stream. So it takes the data stream and then transforms it and emits new data. So you can see, like I told you, I actually exclude the Obama and Romney terms. But then all I do is parse things and then store them back so I know what my domain of numbers is. And then I stream the data stream to the transform stream, and then I pipe it out to socket.io. Socket.io is not streamable, so it's in quotes, but you get the basic idea. And that's basically it. So we're not taking any questions, so no questions. And so if you want a Splunk shirt, and I totally forgot to take off my sweater. I have this awesome shirt under it, but I'm not going to do it on stage. It's not a strip club. So mention Splunk Dev for a t-shirt. We have some awesome shirts that we like. You can also stop by our office. It's in South Lake Union, right by the Whole Foods. If you're interested in what we're doing, we're hiring, we're growing the office here. We'd love to have people join. Thank you very much. And then I'm going to leave you with, we needed a new dev t-shirt. And so we suggested to marketing that it's going to be like require bigger boat, like a module called bigger boat. And they rejected it because they said that nobody understands the reference. Thank you. Yeah. Okay. And then FedEx came and they had this poster that said like you're going to need a bigger box and like a shark, like a plush shark that couldn't fit in the box. It's like it's not like FedEx is a global brand or anything that people know FedEx is. But so we rose up to the marketing challenge and I wrote this module. So you can install this for real. npm install-g bigger boat, and then you type bigger boat, and the shark is going to tell you you're going to need a bigger boat. Okay. Thank you very much.